Okay, welcome to week 6. Now, very often when I'm teaching this in a live setting, we end up running about an hour and a half behind by the end of the 6 weeks. And so it's common, pardon me, it's common that I end up teaching the string handling stuff during the first hour and a half of week 6. But we have pushed through pretty hard, particularly in week 3, and consequently we're already done with this string handling material. I ended up covering that last week. So all we have remaining here in week 6 is to talk about classes in Python. We've been using some built-in data structures, list, tuple, set, and dictionary. Also string to a certain degree. And these built-in data structures respond to both symbolic operations as well as named operations. So we can do things like list sub5 with square brackets. We can also say list dot append and an item value to append a value to the list. What we're interested in doing here in this section is to give you a taste of how you can define classes of your own that keep track of some collection of data. These are referred to as the data attributes within each object of the class. A class is like a data type, and an object is a particular instance of that data type. So for data attributes, we have to have variables that keep track of the current state or the current knowledge, if you will, of the current object. And we have methods, which are functions, although some of these things can be special functions that are treated, that can be accessed using operator symbols like plus and times and so forth. These methods provide the so-called behavior of the objects of the class. Now, it's also possible within a class to have a nested class, but that's a little beyond what we need to worry about for this introduction. Okay, so let me zoom ahead to this stuff. Now, so a class consists of a collection of method or function definitions, and also we can have what are called class variables that we'll get to a little bit later. All of the methods that you define for a particular class receive as the first argument a reference to the current object itself. And the name that's used for that argument is conventionally self. You can call it this or me or what have you, but self is the conventional argument name. And there are two methods that we're always going to want to define for any class that we create. First is the underscore underscore init underscore underscore. That is the dunder init function. This is the constructor for the class, and it's the function, it's the method that knows how to create and initialize a new object of the class. We're also, for certain, going to want to be able to display the current object, an object of the class, in a human readable format. And so dunder stir is another function that we should always create that is able to translate the current object, whatever data members it might have, into a stir object so that the thing can be displayed. All right, so init, dunder init, and dunder stir we are always going to want to define for any class that we create. Let's imagine, for example, that we want to write a human resources application in which we want to be able to create and interact with employee objects. Okay, so we think about what do we need to know about each employee that we have. Well, at least we're going to want each employee to have a name, and we're going to assign a company ID number to each employee, and we're also going to want to have an hourly pay rate for each employee. Now, in real life, of course, there's a ton of other things that we would like to know about each employee, like social security number, home address, home phone, cell phone, on and on and on. But to illustrate what's going on with classes, it's enough for us to know that for each employee, we're going to have these three data attributes. Okay? Now, in terms of what we want to do with employees, okay, here on slide 25, this is what we want each employee to know about itself. We want each employee to know about itself, its name, its ID number, and its hourly rate. In terms of what we would like to be able to do with employees, we would like in our company to be able to hire a new employee. This means that we want to be able to create employee objects within our program. We also want to be able to convert an employee to a string so that we can display a human readable representation of the employee's name, ID, and rate. And because we're nice, as a third thing we would like to be able to do, we would like to be able to give an employee a raise. Now, I said because we're nice, but actually we can give the employee a negative raise, so maybe we're not so nice after all. Anyway, so let's take a look now at how we implement these concepts here of what each employee knows about itself. What each employee knows about itself and what each employee is able to do in Python code. Okay, so to create the class employee, we say class employee colon. So this is a bit like defining a function or like defining an if or like defining a for loop, except this time the keyword is class, and we pick whatever class name we would like. Conventionally, class names start with an uppercase letter, but that's not a requirement. And within this employee class, indented one level, we have the three methods that we want each employee to be able to do. That is, we want to be able to initialize or create an employee object. We want to be able to convert an employee object to a human readable string. And we want to be able to give a raise to each employee object. All right, so let's take a look at the internals of each one of these methods here. All right, so each method is a function, so we're using define, def, to define the function. And notice that the first argument to each one of these things is self. All right, self, self, self is the first parameter, the first argument to each one of these function definitions. Now, when we initialize an employee, what that means is that we need to have variables that contain the knowledge about the current employee. And the knowledge that we expect each employee to keep track of about itself are the name, the ID number, and the rate. And so these are passed in as arguments. Name, ID, and rate come in as 3 argument values. And notice that we're using underscore name as the variable into which the name value is going to be stored. And that underscore name variable is within the current object itself. Okay, so underscore name is not a global variable. Underscore name is what's called an instance variable. Each employee object, each so-called instance of an employee object, has within itself this underscore name variable, keeping track of that current employee's name. Similarly, we've got the underscore ID and underscore rate instance variables keeping track of the ID number and the hourly rate for the current employee object. I'll say something about what these underscores imply in a moment. Okay, so every employee object that we hire, every employee object that we create within our human resources application is going to be initialized with a name, an ID number, and a rate. And those are going to be stored within the current employee object that we're creating with these names underscore name, underscore ID, underscore rate. And we use the self dot notation to indicate that these variables belong to the current employee object itself. They're not global variables. Now, when we convert one of these things to a human readable string, these parentheses here surround the string value that I want my dunder_stir function to return. And basically all I need to do is to convert the ID number and the name and the rate into strings and concatenate them together with some other literal strings using the plus concatenation operator, and then return that operator. So what are we returning here? We're returning the literal stir ID colon space, followed by the ID number. Now, I haven't said so, but let's presume that that ID number is an integer. So we're going to convert that ID number into a string and concatenate that onto the end of ID colon space. Then onto the end of that converted integer, we're going to append another literal string, comma space, name, colon space. And then we'll append the name of the employee. We're assuming here that the name is already a stir, so that we don't have to convert it to a stir in order to be able to append that. After we've converted the name, we're going to append or concatenate comma space salary colon space. And then the rate that the rate that the current employee has, we don't want to show more than 2 decimal places for the hourly rate. So we're using our good old format function, and we're saying, let's format the rate. Aha, I just noticed I have a typo here. There should be an underscore in front of rate there. Okay, so that should be self._rate, because underscore rate is the name of the instance variable for the current employee keeping track of the hourly rate. All right, so we're going to format the current employee's underscore rate as a fixed point number with 2 digits after the decimal point. So if we hire an employee and we say, you know, we're going to pay you 15 2/3 per hour. Well, we can't literally pay them 2/3 of a dollar per hour, so that'll get rounded up in effect to 15.67 when we represent that as 2 decimal places. Okay, so that's the initialization function and the string conversion function. The third function, called giveRaise, takes a percentage as an argument. Now, the percentage, that's an integer value. I was going to say a number between 0 and 100, but actually we're going to allow negative percentages as well. And we could, in the case of a phenomenal employee, give a greater than 100% raise, of course. So we're going to convert that argument into a fraction by dividing the percentage by 100 and then adding 1. And so the employee's rate is going to be either increased or decreased by that factor. Alrighty, so there's the code for implementing the employee class. And here Continuing on in the same file, very likely the name of this module is something like employee.py. And so underneath the class definition code in that same file, we have our test whether dunder name is equal to dunder main. And if so, we will hire a couple of employees and test them out. So we're going to create an employee object named John with ID number of 1 and hourly rate of 60.5. Okay, so the init function will be invoked for this employee object, and the employee object is then going to be referred to by this variable John with the lowercase j. Now, because we've defined the stir method, I can convert John into a stir and display John. So what's going to come out is ID colon space 1 comma name colon space John comma salary colon space 60.50. All right, so that's what will be printed here. Now, it turns out that one of the behaviors of the print function is that it automatically invokes the stir method on each object that you give it as an argument. So in fact, when I say print John, without bothering to call stir, stir actually gets called implicitly by the print function itself. And so saying print stir John is just a long-winded way of saying print John. These two different function calls accomplish exactly the same thing. Okay, so all we're doing with this employee John is to create the employee and then display the information about the employee 2 times. For this next employee, Ed, we are creating Ed and displaying Ed. Then we're going to give Ed a 10% raise and display Ed again. All right, so let's see how this actually, what we see on our screen when we run this code. Okay, so we are creating this employee John and then printing John twice. In each of those print function calls, we get the same output. ID colon space 1, comma space name colon space John, comma space salary colon space, and then 60.5. Now, this, I think, is also a typo. This should be 60.50 because we have explicitly said that we want 2 digits after the decimal point. So I think I have a typo on my slide there. Okay. All right, and then for Ed, notice that Ed's original salary that we specified was 72.25, but after the 10% raise, Ed's new salary is now going to be 79.48. And this 8, of course, is rounded. 72.25 plus 7.225 is going to give us exactly 79.475. But we can't pay somebody a half a penny an hour, so that gets rounded up to 48 cents an hour. Now, here's one of the weird features or misfeatures or whatever you want to call it about Python relative to more strict object-oriented languages such as Java or C++. It turns out that any attribute within a class can be accessed from any code anywhere else in your program. So if you're familiar with Java or C++ or C#, the implication here is that everything that exists within a Python class is implicitly public. And in fact, there's no way to force anything in a Python class to be private. What we do as a sort of a weak pretense at making things private is to stick an underscore at the front of any class member that we want outside developers to respect as being private. Okay, so respected here means that we are saying it's like we own a house and we're saying to our neighbors, dear neighbors, we can't lock our house, but we've put an underscore in front of the door, so please respect our house. Don't come into our house and mess our stuff up. All right, so that's this lame underscore thing, and so that's why we're using underscore name, underscore ID, underscore rate for the names of these data attributes, because we want people using the employee class in their own applications not to directly mess around with the name, the ID, and the rate for a given employee. But that's not enforced. And so here we have some code that some user of our employee class, some other application developer, we've created the employee class, and here is some other application developer using our employee class who is just blowing right past our request for privacy and comparing, well, is John's rate greater than Ed's rate? All right, we're just directly going in and accessing underscore rate from John and underscore rate from Ed. If John's rate is greater than Ed's rate, we're going to say John makes more than Ed. And again, we're just going right to the supposedly private, the supposed to be respected private rate and name of the employee objects. And this code runs fine. If we try to do something like this in Java or C++ or C#, it would not, well, in those languages, it would not compile. Of course, Python is interpreted. But the fact that it's interpreted doesn't have anything to do with privacy or lack of privacy. Everything is only private out of respect, and here we're not being respectful. Okay. Okay. So what can we do as a class developer to try to make it less likely that someone using our class is going to violate our expectations about privacy of data attributes, or for that matter, of what are called helper functions? You can sometimes have what are called helper functions or helper methods within a class that the class methods themselves call for support, but that we don't expect outside users to make use of. Okay, well, what we're going to do is we're going to define a bunch of set and get methods to set the values of data attributes or get the values of data attributes. And we hope that because we provided these functions, that the other developers using our class will use these functions rather than blowing past our privacy expectation. Now, in one of the data attributes, okay, remember that for our current implementation, for each employee object has a name and an ID number and a rate. People's names can change. Okay, we can, I mean, one obvious case is, in the United States, in every state, if you get married, you're permitted legally to change your name when you do that. You're also able to go to court and indicate that you would like to change your name, and the court will either grant or deny that request. Typically grant the request unless there's some really bizarre reason not to. Okay, so there is a basketball player whose name is Meta World Peace. And believe it or not, Meta World Peace was not this basketball player's original name. So that was a legal name change. Now the ID number, however, for an employee, that is something that a company never wants to change. So when you get hired by a company, you will be assigned, in all likelihood, a unique employee ID number that will never change. In fact, even when you leave the company, and if they hired you back again later, it's likely that you would be given the same employee ID number again upon your return that you had the first time you were hired. So we are going to not define a set method for the ID number. And we're really going to hope that someone developing an HR application using our employee class won't just arbitrarily decide to start changing people's ID numbers. Okay, so here is our new and improved implementation of our employee class. We still have dunder init, dunder stir, and give raise. These methods have not changed, but we've added 2 new methods for setting the name and setting the rate, and 3 new methods for getting the name, getting the ID, and getting the rate. And so we hope that someone using our class will now be respectful, and instead of going in and directly accessing underscore name, underscore ID, and underscore rate, they will call the set and get functions. And they will take the hint that because there is no set ID function, that means that an ID number for an employee should not be changed. All right, now that we have added get name and get rate, okay, we've got get name and we've got get rate in here, we've now made it possible for an application developer to call those functions rather than directly accessing underscore rate and underscore name. So here we have a revised application, some revised application code using our new and improved employee class, and we're saying John.getRate, if that value is greater than Ed.getRate. So we're still comparing John's rate with Ed's rate, but we're being more respectful, and we're allowing the employee class to tell us its rate rather than digging right into the employee object and yanking out the rate. Okay, and similarly for get name, we can get the name that way. Okay. So as I already mentioned, these underscore name, underscore ID, and underscore rate variables are referred to as instance variables. Each instance, each separate copy, if you will, of an employee object has its own underscore name and its own underscore ID and its own underscore rate. All right, so John's underscore name is distinct from Ed's underscore name, and so forth. Sometimes, though, it's useful to have a variable that belongs to the entire class. And such a variable is called a class variable as opposed to an instance variable. All right, so underscore name is an instance variable. Each individual employee object has its own. But we might, as a class variable, want to keep track of how many employee objects have ever been created, let's say. So it's not interesting for John to know how many other employee objects currently exist, or for Ed to know how many other employee objects currently exist. But it is useful for the employee class as a whole to know how many employee objects have ever been created. And we could also keep track of how many employee objects have been destroyed, that is fired from our company or whatever. In order to set up this class variable, we define the class variable outside of any of the method definitions. So here's how that looks. Here we have got, and notice that this is outside of dunder init or dunder stir or give raise. Here we've got this variable num created initialized to 0. That variable belongs to the class as a whole, not to any particular instance of the employee, not to any particular employee object. All right. So num created is initially 0 when we import this module containing our employee class. And each time we hire an employee, that is, each time an employee object is created, we're going to want to increase that num created variable by 1. And notice how we do that. We say employee.num created is incremented by 1, as opposed to self._name, ._id, ._rate. So these ones that assign to something belonging to self, those are the instance variables, whereas num created is a class variable. Okay, and then how do we access that variable? Well, one way we can access it is to give the class name and a dot and the name of the variable. And that will just directly access that variable from within the class. Now, it turns out also that you can, if you wish, use a particular instance and .num created, and that will also work. But it's not necessary for you to have any instances of an employee object currently around. That is, when you launch your company, you haven't created any employees yet. You haven't hired any employees yet, but you would like to be able to query how many employees does my company currently have, and you would like to get told, oh, your company currently has 0 employees. Okay, so we would most commonly use the class name and the class variable name to access that class variable name within the class. But you can do it with an individual object, an instance. Now, there is no global variable called num created. Okay, num created exists within the employee class. It's not global, so if you attempt to print num created directly, you'll just get an error message. Unless you accidentally also have a global num created variable sitting around, which is separate from the employee class's num created variable. Okay, so if we were to append these two print statements on the bottom of our existing code, we would get told that there are 2 employees that have been created, because John has been created and Ed has also been created. Another feature of object-oriented programming generally, regardless of language, and this is true in Python as well, is that object-oriented programming supports the idea of inheritance. That is, it supports the idea of being able to say that some class is a kind of some other class. Pragmatically speaking, one of the advantages here is that you don't have to rewrite a whole bunch of code when you implement a new class that is simply a kind of some existing class. In our case, since we have employee objects, we might also want to be able to create manager objects. Well, a manager is a kind of employee. A manager also has a name, an ID number, and a rate. And a manager also needs to be able to be initialized and converted to a string and given arrays. But a manager has some additional state, that is, some additional instance variables, and some additional responsibilities or behaviors beyond what an ordinary employee has. For example, a manager is probably going to have a budget, and a manager is going to have a list of employees that report to the manager, and these kinds of things. So here's how we can do this inheritance idea in Python. We're going to import employee. Now, previously I had said that probably our employee code was in a module named employee.py. Here I'm making that assumption quite explicit, and I'm saying import employee, which is going to go look for this employee.py file. And we're going to import employee with the abbreviation EMP. This file is our manager.py file. And so what I'm doing here is defining the incremental code necessary to implement a manager class. The notation up here says that manager is a class. It is a kind of employee. Okay? So in parentheses, we give the name of the class that this, I'm trying to think, okay, I do too much C++ programming. In C++, these are referred to as, employee would be the base class, manager would be the derived class. In Python and Smalltalk and certain other languages, we refer to the employee class as the superclass and the manager class as the subclass. Okay, because the employee, you think of these in terms of sets. The employee is the superset, and the manager is the subset. Every manager is an employee. Not all employees are managers. All right, so employee is the superclass in which manager is a subclass. I personally, and apparently many people, find that sort of confusing because the manager objects respond to more methods than the employee objects do. So it's awkward thinking of a class that responds to more behaviors as being a subclass of a class that responds to less behaviors. But nevertheless, that is the terminology that's used. So employee is our superclass, and manager is our subclass here. All right, so for the manager class, we're going to need to define the dunder_init function that initializes a manager. We're going to need to define a dunderStir function that displays or that converts the internal representation of a manager into a string that we could then display. And our manager, in addition to being an employee, also has a budget that we have to be able to set and get. Now, because a manager is a kind of employee, what that means is that when we give the name, ID, rate, and budget arguments to the dunder_init function for manager, we can simply turn around and call the init function with the name, ID, and rate for the superclass, which in this case, the superclass is employee. So we're going to invoke the superclass's init function to keep track of the name, the ID, and the rate for this manager object. And at the manager level, all we then need to do is to keep track of the underscore budget additional data attribute and assign the argument value passed in to that underscore budget variable. Similarly, when we convert a manager into a string, we were careful to write our employee class's string handling or string conversion function in such a way that we can ask for the employee class's stir conversion function to be used, and then we're just appending a little bit more text. We're appending comma space budget colon, and then the budget value to convert the manager into a string that can be displayed. Then these incremental methods, set budget and get budget, are quite simple. We pass in a budget argument, and we assign that into the underscore budget attribute, or else we just return the underscore budget attribute. So this means that a manager is a kind of employee, and for the manager, therefore, we can get the name, set the name, get the ID, get the rate, set the rate, get the budget, set the budget. We can do all of the behaviors that an employee object can do, but we also have these additional couple of behaviors, set budget and get budget, and that requires us to have an additional instance variable, namely the underscore budget instance variable. All right, and so here on slide 41, we have added to our test code the hiring and displaying of a manager whose name is Anne. Now, because this manager class module has imported the employee class module as emp, I can, within this manager class code, I can invoke emp.employee to create an employee object. All right, so I can still create John as an employee. All right, so John is name John with ID number 1 and rate 60.50. Then we're going to print John once. Now this next print function here, print with no argument, just means to print a new line character. So that's just going to print a blank line. Remember that the behavior of print is to print out each of the argument strings separated with whatever the separator is. By default, the separator is a space, and automatically add a new line character at the end. So if I just say print open close paren, all I get is the new line character. All right, so I create John and print John, then I create Ed, print Ed, give Ed a raise, print Ed again, and then print a blank line. And the last thing I do is to create this manager called Anne and print Anne. The output of that is shown on slide 42. Interesting. Okay, so I have a bug here in my output. I should only have John being displayed one time. We're creating John and printing John, and then we're printing a blank line. So somehow I got my blank line correct, but I printed John twice by accident. Then we are creating Ed, printing Ed with Ed's original rate. Then we're giving Ed a 10% raise and printing Ed again with that 10% raise. Finally, here we're creating Anne as a manager and printing out Anne. And notice that because we called super dot dunder stir, that the initial three parts of output for Anne are in the same structure, the same format as for an ordinary employee. But then we've also got this incremental stuff on the end where we tacked on comma space budget colon and then Ann's budget. All right, well, so that gets us to the conclusion of this hasty introduction to defining classes. This is, as I said, this is for your information. It's sort of the next logical step in your evolution of being a skilled Python programmer, but we won't have time to actually make use of that directly in our data-focused Python course.
Okay, I hope everybody's projects are going well, and I look forward to seeing your projects and your presentations.